This related rate problem is about volume of oil in a cylinder. Oil is pouring into a vertical cylinder at 2 cubic meters per minute. So oil is pouring, and you can see that the volume of this oil is increasing, right? Because the oil is pouring, you have more and more oil in the volume in the cylinder. The cylinder is measured at height 16 meters and radius 3 meters. So I have a graph. So for the graph, for most of the related rate problem, they won't give you a graph. So it is your responsibility to draw the graph, make sure the graph is nice, and then label what is given. So we have the graph, and then radius 3, height is 16. The question is asking how fast is the oil rising. So the oil is rising, that means the rate of change must be positive when the cylinder is 3/4 full. So the volume of a cylinder is pi r squared times h. The concept is pi r squared is the area of a circle, and you are stacking up this circle one on top of another. How many copies do you need? The answer is you need h numbers of copies. So after you stacking up h copies, then you will go from two-dimensional one piece of circle to one stack. So you will get a cylinder. All right, and then the next step is don't move on to the derivative yet. You have to know what is given and what is not. So let's state the givens. So we have givens. What's the first given? The first given is the first sentence. The oil is rising, right? So oil is pouring into a vertical cylinder at 2 cubic meters per minute. So we know that the volume is changing. So dV dt, they are all changing with respect to time. How do I know this? Because this is a minute. So I know that the volume is changing with respect to time. You can write this down. The volume is changing. The height is changing with respect to time. So dV dt is equals to positive 2 and then cubic meters per minute. The reason I mention positive is sometimes the problem will say that you have a tank and then the tank is leaking, and then they ask for the rate of change of the volume. So in that case, since the tank is leaking, you are losing oil, then that becomes a -2 or a -2. All right, so you have to specify the plus and the minus. And then how about the radius? So the radius is equals to 3 meters, right? And this one is fixed, no change. What does that mean? That means there is no the derivative of radius with respect to t, because the radius is not changing. So radius is not changing. And then what else? Is fixed, not changing. And then the height is 16, right? So the height is equals to 16, but they only ask 3/4 of it. So 3/4, how do you calculate 3/4? So that is 16 times 3/4, right? So that is 3/4. So we have 4 times 3. That is equals to 12. And then they are looking for what? They are looking for how fast is the oil rising. Then they are looking for dH dt then. So they are looking for dH dt. They don't know what that equals to. So when you take the derivative, before you take the derivative, do you see that the r is not changing? So it is safe to plug in the 3 right now. So we have a 3 square right now because that is not changing. And then the rest, we have to take that into account. So v is equals to pi 3 square times h. So now we take the derivative. So this is not just v prime. So I prefer to write dv dt because that is changing with respect to time. And then this is a 9 pi, right? Just a constant. The derivative of h is equals to 1. And then you have to mention dH dt. This is implicit differentiation. Implicit differentiation. Since the volume and the height, they are changing with respect to time, you have to mention this. Okay, don't just say, okay, the derivative of h is equals to 1. Yes, the derivative of h is equal to 1 because this is a related rate problem and you are doing implicit differentiation. Let me just write it down. Implicit differentiation. You have to take the dH and the dV dt into account. Okay, now time to do the plug-in. We have a positive 2 equals to 9 pi times dH dt, and then you solve for dH dt. So what is dH dt equals to 2 divided by 9 pi. If the problem did not ask you to round, don't round anything, leave it as it is. So the dH dt, that is equals to 2 divided by 9 pi. So this is your final answer. And then what is that means? That means the oil is rising because it is positive. If that is negative, that means the oil is leaking. At is leaking is the oil is coming out from the cylinder. If that is negative, at positive 2 over 9 pi, the unit is cubic meters per minute. All right, so that is, we just found the HDT, and that is the end of this video and the end of this problem. If you like the way I explain related rate problem, give me a like, share, and subscribe to my channel. Truly appreciate your help, and I will meet you all in the next video for another related rate. See you there.